Hello, everyone, and welcome to the first episode of a new lifelong learning offering from your William and Mary Alumni Association. I'm Matt Brandon, class of 92, and Associate Vice President for Alumni Engagement and CEO of the William and Mary Alumni Association. Thank you for joining us for this program that is the first episode of William and Mary Alumni Association's Lifelong Learning Series. One of the many reasons I love being part of this community is that learning doesn't end after you graduate. Through our lifelong learning series, we bring alumni, parents, friends, and members of the broader community together to explore timely topics, engage with faculty and experts, and continue the intellectual curiosity that has always defined William and Mary. From advances in science and public policy to history, leadership, and emerging technologies, these programs help us stay connected to one another and the ideas shaping our world. Today's webinar, AI for All, focuses on one of the most transformative developments of our time, artificial intelligence. AI is disrupting nearly every industry, rapidly changing how we learn, work, create, and solve problems. As these technologies become increasingly woven into our daily lives, it is essential that we understand both their possibilities and their limitations. Today's session is designed to provide a foundation for understanding AI, what it is, how it works, where it excels, and where its limitations lie. In the next installation in this series, we will take a more hands-on approach, focusing on practical ways to use AI tools in your personal life, your workplace, and your everyday problem solving. I would like to thank Dean Doug Schmidt for sharing with us today. I want to thank you all for being with us. Your continued engagement and support for William and Mary, and your curiosity, the desire to keep asking questions, exploring new ideas, and engaging with an ever-changing world is what makes events like this possible. We encourage you to explore the lifelong learning calendar on the Alumni Association's website for more upcoming events and opportunities to continue to grow alongside fellow members of the William and Mary community. And with that, I'm going to turn it over to today's moderator, William and Mary student, Allison Morris.
Thank you, Matt, and thank you all for joining us today. My name is Allison Morris, and I will be starting my senior year at William & Mary this fall, where I'm double majoring in computer science and history. I also serve as the chair of the Association for Computing Machinery, or ACM, one of William & Mary's largest student organizations focused on technology, computing, and professional development. I'm currently interning this summer as a software engineer with General Atomics in Charlottesville. I share that background because I think it reflects one of the reasons I'm so excited about today's topic. AI is often viewed as something reserved for computer scientists, engineers, or large tech companies. But one of the most important things I've learned through my studies and experiences is that AI is increasingly becoming a tool that can be applied across disciplines and industries, and by people from all backgrounds. To give you an example of how we can apply AI outside of the tech industry, this past year, through a partnership with the Colonial Williamsburg Foundation, I've been involved in using AI-assisted image rendering to help visualize what parts of Colonial Williamsburg may have looked like in the 1600s. These images are being developed to support museum exhibits and educational programming, as well as to help train volunteers and interpreters who bring history to life for visitors every day. For me, that project illustrates both the promise and the complexity of AI. On one hand, these tools can help us create new ways of understanding and sharing knowledge. On the other hand, they raise important questions about accuracy, interpretation, bias, and the role of human expertise. AI is a tool that is meant to augment human thinking, not replace it. As they are teaching us at William & Mary, AI works best when paired with critical thinking, the ability to question the results, and subject matter knowledge. That's really the goal of today's session. Rather than focusing on specific tools or technical details, we want to build a shared understanding of what AI actually is, how it works, what it does well, and where its limitations lie. Whether you've already experimented with AI or are simply curious about all the attention it's receiving, we hope you leave with a stronger foundation for understanding both the opportunities and the challenges that come with this technology, and you will hopefully join us for the second session that will involve a more hands-on tutorial on how you can use these tools in your personal and professional lives. In just a moment, I'll turn it over to Dean Schmidt, the inaugural Dean for the School of Computing, Data Sciences, and Physics. Before we begin, I'd like to let everyone know we are recording this webinar, and it will be made available on the Lifelong Learning website for those who would like to revisit the discussion or share it with others. Following Dean Schmidt's presentation, we'll transition to a live Q&A. We already have several questions lined up to get us started from those submitted during registration, but we encourage you to continue the conversation by submitting additional questions throughout the program using the Q&A panel. We'll do our best to get to as many as possible during our time together. Again, thank you for being here today, and at this time, I'll turn it over to Dean Schmidt.
Super. Thank you so much, Allie. Thank you, Matt, for the introductions. Looking forward to spending the next 45 minutes or so with everybody. I'm Doug Schmidt, class of 84 and 86. I was a sociology major here at William & Mary, and now I'm very proud and honored to be back as the dean. So what I'm going to do today is talk about what I like to call the democratization of computational thinking. And we'll see how this is affecting education at William & Mary and beyond, how it's affecting our daily workflows and practice, and also prepare us for our increasingly AI-augmented future. I'll also be providing the slides I'm presenting here along with the video when it's available. So before we jump into AI, let's take a step back and take a look at what's been happening over the past 70 years or so in the world of computing, which has been a gradual evolution from the how to the what. What do I mean by that? Well, if you go back 70 years or so before I was born, you can see that people spent most of their time wiring machines together in order to be able to directly control the computer by toggling in the instructions on the front panel of the computer. As you can imagine, that was very low level, it was manual, it was rigid, and it was very expensive. For the past 60 or so years, we've moved from wiring machines to writing code, using programming languages, using various tools and platforms. This has made it possible to be more flexible, more powerful, but it's still complicated. And as we'll see in just a moment, a lot of people wrestle with that complexity for good and bad. Where we're headed now, because of the influence of AI and other advances, is moving not from writing code and programming languages, but to describing our intent, what we want to have happen in natural language. And we collaborate together with things like large language models, which are basically AI tools that know how to respond in a conversational way, all the way up to things like agents, which act with some degree of agency to carry out tasks that we program them to perform. And increasingly, we program those tasks in natural language. So what this is doing is it's helping us focus more on what matters most: problem solving, driving business value, helping to shape the future in all kinds of interesting ways. Before we get into the AI, though, let's take a look at another example of how this has occurred over time. And the analogy here is the evolution of automotive technology from the how to the what. So if we go back 120 years or so ago to the turn of the last century, if you wanted to drive a car, you had to know how to build a car. If you go back 70 years or so to the 50s, if you wanted to drive a car, you had to know how to maintain the car. Change the oil, check the carburetor, keep your fingers crossed it will start on a cold day. Nowadays, to drive a car, you pretty much have to know how to plug it in or how to fuel it. And increasingly, you don't even have to know how to drive a car. I've been in New York City recently. I was in San Francisco for a William & Mary alum event a couple months ago. Was in Nashville to see the Eagles play recently. And all three of those cities have driverless taxis by the Waymo service. And so all you have to do is just hail the taxi through your app, get in the taxi, and it takes you to your destination. In fact, when I was back in Nashville recently, seeing the Eagles play at the Vanderbilt football stadium, when we drove to the airport the next day, the person in the Uber driver, didn't touch the steering wheel, didn't touch the foot pedal, didn't touch the brakes, the accelerator, etc., and drove us the entire way from the hotel downtown Nashville to the airport just by letting the car drive itself. That was both exhilarating and terrifying at the same time, but it's the shape of things to come. Now let's take a look at what's happened in the computing world. And this, you'll see very quickly, generalizes to many other domains besides just computing. If you wanted to use a computer 70 years ago, You had to know how to build software and probably build the hardware. You had to figure out how to wire the pieces together. In fact, when I came to William & Mary in the early 1980s, we were still programming with punch cards. And I had several friends in my freshman hall who were computer science majors until they dropped their deck of cards. And the next day they were sociology majors or history majors because it was so difficult to deal with things at that time. When I started programming at William & Mary back in the mid-80s, we wrote programs manually using relatively low-level languages like Pascal or C, and we had to do all the debugging manually. It was very tedious and error-prone. I loved it, but it wasn't easy. It wasn't for the average person to find interesting and compelling. Up until about 6 to 9 months ago, people were programming primarily by assembling programs, by picking the right libraries, using frameworks, and plugging things together with what are called APIs, or application programming interfaces. What's happened in the last 6 to 9 months is nothing short of amazing. Programmers increasingly don't write code, certainly not the way I did when I was at William & Mary 40 years ago. They're not even writing code the way we did 6 to 9 months ago. Instead, they're saying or typing what they want in natural language, and then they're letting teams of autonomous AI agents generate, adapt, and test the solution. If you want to find out more about this, there's a wonderful video from Google that I have in the link at the bottom of this slide, which I'll make available. And starting around the 4-minute and 30-second mark, they talk about how they're developing their workforce to use agentic coding. Now, it's no surprise that this has happened to programming because programming lends itself to automation. It always has, and now it's increasingly lending itself to automation because there's so much source code available to train models with. So this has been one of the first areas to really adopt an agentic approach to building systems. However, it is by no means the last domain to go the agentic direction. Accounting, marketing, healthcare, legal profession. Increasingly, we're seeing people start to adopt agentic approaches where teams of autonomous agents are working together with people in order to be able to expand productivity, and as I'll get to in just a minute, enable tremendous amount of creativity because it helps to essentially offload occupational bureaucracy. I'll talk more about that in just a second. What's at the heart of this evolution? What's really at the heart of this is something known as computational thinking. Computational thinking was a term that was coined and popularized by Dr. Jeanette Wing, who at the time was a computer science professor at Carnegie Mellon University. She later went on to be the head of the National Science Foundation's Computing and Information Systems and Engineering Directorate. Then she was the vice president of research at Microsoft, and now she's the executive vice provost for research at Columbia University. And roughly 20 years ago or so, she wrote an article in the Communications of the ACM, which is a popular publication about computing, talking about computational thinking. And what she said it was, in a nutshell, was it was a universally applicable attitude and skill set that everybody, not just computer scientists or computer programmers, should be eager to learn and to use. So what are really the components of computational thinking? Well, here they are. There are 7 of them, which is fortunate if you're a student or a follower of Harvard psychologist Henry Miller, who had the famous 7 ± 2 model for things you can keep in the back of your mind with your short-term memory. So the first thing at the heart of computational thinking is the ability to do logical reasoning, applied structured reasoning to evaluate options, make decisions, and draw reliable and hopefully empirically or logically grounded conclusions. Beyond that, though, we also have the need to know how to do decomposition, break big, complex problems up into smaller, more manageable components that we can then analyze, solve, and integrate back together again in systematic ways. Also very important is the ability to identify patterns, which are similarities, trends, and recurring structures that reuse helpful knowledge to accelerate complex problem solving. Also important is abstraction. I use a picture of an iceberg here for a reason. Abstraction is about focusing on the essential elements while filtering out the implementation details to allow people to work with simpler, more useful models. Just like an iceberg has only a piece above the surface, but a lot more below it. Also important is design, which involves creating structured and scalable solutions by defining components, interactions, constraints, and workflows that achieve desired goals precisely and effectively. One of the key things we're going to talk about and see an example in a minute is automation, which is how to allow computers or AI to execute problem solutions efficiently with minimal effort from humans. And then finally, very important, and we'll come back to this in a minute as well, validation, testing, verifying, vetting, refining the solutions to make sure we have accurate, reliable, and aligned outputs with the goals that we're trying to achieve. So those are the 7 elements. The key thing to note here is that computational thinking isn't really just about coding or programming. It's about a process, a mental process of solving complex problems by breaking them up into smaller, structured, and repeatable processes that either humans and/or computers and machines can perform. What's interesting, however, is over the past 70 years, computational thinking historically required knowledge of programming languages. And if you're a software developer, you recognize the words on this slide. If you're not a software developer, you're probably looking at what appears to be the Tower of Babel. It's just a bunch of names, but we see Java, C++, Python, Ruby, JavaScript, and so on. Now, it's great for those of us who like to revel in the complexity of programming. However, programming language fluency adds a number of accidental complexities that have nothing to do with the problem we're trying to solve. They're because of the challenges and the low-level ways in which we have to write computer programs. Examples would include things like syntax, semantics, memory leaks, concurrency bugs, buffer overflows, off-by-one errors, error handling, security, distribution, and so on. And for those of you out there who are looking at this list of words and wondering, what the heck is he talking about? That's exactly the point. These are very low-level, complex things that to be a successful programmer in the traditional way, you had to be very facile and fluent with. But when you're trying to solve problems, to some extent, they get in the way. Well, it turns out it doesn't have to be that hard to think computationally, but those of us who've worked in the computing field for a long time have somehow mistaken these accidental complexities for necessity. And it turns out in many cases, they're actually not that important. Some of them are important, but in many cases, they're not. So let me move away from 7 abstract concepts floating around in thin air and give you a very concrete example of how I've applied computational thinking with agentic AI to solve some very practical problems in my daily workflow. So we're going to talk about an example agentic framework called Opal. And you can, if you have a Gmail account or a Google account, which most of you probably do or could get easily because they're free, you can play with Opal yourself. It's freely available. You can experiment with it. The link at the bottom of this slide gives you the link to get access to the Opal agentic programming framework. And what you can do with Opal, as we will see in just a moment, is you can apply natural language and you can use a visual editor if you prefer to describe a workflow you want to streamline and optimize. So I'll give you an example. I give a lot of talks. I have lots of talks on my YouTube channel, about 3,400 of them, in fact. I'll show you a link to that later. And often what I want to be able to do is take a talk I give, like this talk, for example, and break it up into smaller, more reusable pieces, more accessible pieces. For example, I might want to take a longer talk, maybe a 10-minute talk, and turn it into a blog posting that distills the key essence of my talk. Likewise, I might want to take my longer talk and create a short 20-second teaser video that will drive engagement for people to watch the longer video, kind of like a trailer for a movie. And I also might want to generate AI podcasts featuring conversations between people who are talking about my talk. If you've played around with Google's Notebook LM, then you know what I'm talking about when I talk about podcasts where people talk about some topic. So those are 3 things I do a lot, traditionally done it manually. And what I did, and this is kind of a theme throughout this presentation, I always look for parts of my daily workflow that can be optimized and streamlined through judicious and effective use of AI. And so I created a little mini app that will transform a single video of either mine or somebody else's, into a complete multimedia package. And let me show you how I did this, because it's really instructive to demonstrate how easy it is to use AI and the ways you can help your workflow be more efficient. So this video content creator mini app was created by me using Opal with a single simple prompt. And here is the single simple prompt, and we'll break it up into a couple of pieces. I told it, just by typing into the little window down here, generate a mini app that prompts a user for a video URL, and then create a 1,000-word blog post containing 2 images generated from the video, in other words, to capture, visualize the essence of what I was talking about in the video. Create a 20-second trailer or teaser video. Make a podcast summarizing the video. And then finally, generate an interactive menu to allow the user to select the results that were generated. This prompt that I just gave here embodies several elements of computational thinking. Obviously, I had to think through the logic of what I wanted. I looked for patterns in my usage where I broke it up into 3 things. I applied decomposition to have a 1,000-word blog post, 20-second teaser video, a podcast, and so on. That was decomposition. And Opal pretty much handled the rest. It figured out how to design the app. It automated the creation of that. And then, of course, at the very end, I come back and test it to make sure it's actually working. So here's what happens when you hit the create button. Opal goes off, and within 15, 20 seconds or so, it creates a data flow program that embodies the prompt. And here's what it looks like. So this is actually what happens when you look at the screen after you use Opal. And by the way, this mini app is a great example of what I like to call no-code computational thinking. I didn't write a single line of code, and yet I'm going to get something that's very useful to optimize part of my workflow. So the first thing you can see here is it prompts the user to enter a URL. So let's say I give it a link to one of the videos that I've produced, or really any video that's available through YouTube or anywhere through the web. The next thing it does is it will automatically read the video or watch the video and create a transcript from the video. It takes the audio part of the video and makes a transcript. It knows how to do that. And it also knows how to magically summarize the key points in the video. Large language models and AI are extremely good at summarization. The next thing it does is it internally generates sub-prompts. These are not prompts I wrote, these are prompts it writes that will tell the later phases, the agents we're about to see, to generate a blog post plus a couple of images, a teaser, video trailer, and a podcast. It generates the prompts. You can actually go look at the prompts if you want to see them. And then finally, it feeds those prompts into a group of agents Google has developed that carry out the prompt's instructions. So it will generate images, it'll generate the video trailer, it'll write the blog, it'll generate the audio podcast, and so on and so forth. And then the final thing it does is it automatically writes the JavaScript and HTML, which are ways of basically providing a user interface that will have an interactive menu to display all the results. And what you end up with after it's been given a URL, it walks through all those stages to that data flow diagram, and voila, you've got this neat menu, and then you can watch the video or listen to the podcast or read the blog post in whatever order you happen to want to do. Now, this is pretty darn cool. And what I like about this was from a single no-code prompt, Opal seamlessly produced a multimedia package that streamlined a frequent part of my professional workflow. Doing this previously in the old way of doing things required hours of manual effort on my part, to the point where I often wouldn't even bother doing it because it was just too much work. Using Opal allowed me to automate this, and I can do this for many, many other things in my workflow beyond just making these videos. So let's take a quick go back to the computational thinking 7-piece element model I've described and see how it maps onto what I just showed you. So the first piece was logic. I figured out what I wanted this thing to do, and I expressed it in a concise and structured way. I had also previously figured out how to decompose my problem up into create blog posts with images, create a video teaser, create a podcast. That was the decomposition step. There were also patterns that I recognized in my own daily workflow. I kept doing these kinds of things over and over again, and they were recurring. So I thought, gee, maybe I can optimize this by building an AI tool. And of course, abstraction is at play because I don't say how to do it. I say what I want done. So once again, focusing on the what from my point of view, not the how. That's Opal's point of view. Opal then takes over, takes my prompt, designs a solution with that data flow architecture. Then it automates it so it can run in the sandbox in the background without having to worry about corrupting files on my computer and so on. And then in this particular case, I verify the output. I obviously double check the blog post and edit it before I release it. I watch the video, I listen to the podcast, and may have to iterate if it doesn't quite get what I want. If I was doing this in a production environment, I would set up something where I would have automated tools do a lot of the verification. So I wouldn't have to manually inspect everything. But this is just an example to kind of get the point across. So what's the secret sauce behind all this stuff? Well, this is where we're starting to get into the really cool parts of what's happening nowadays. One of the key new literacy capabilities that people need to become very facile with is called prompt engineering. And prompt engineering allows anybody who has a web browser and a large language model to perform computational thinking without the need to write traditional code. So the way to think about this in the context of what we just talked about is that prompt engineering captures the intent, the what, that prompt I gave for my example, for instance, and then it uses AI tools to convert that intent into the actual implementation, the intelligent action. That's the how. Now, there are two flavors of prompt engineering. The first one, which is the one we're probably most familiar with to the extent that you use AI at all, is what I call prompt engineering in the small. And that involves the way we communicate with large language models and AI tools to get them to help solve our problems efficiently and ethically and so on, using natural language and using something called prompt patterns, which are ways of getting better results from AI tools without having to go out and retrain the models from scratch. So most people are familiar with this. This is the starting point. In the next video in this series, we'll walk through some more hands-on examples so you can try them yourself. But the real exciting part, and where the industry is moving, and certainly where we are focusing our forward-looking attention at William & Mary with the research that we're doing, is what I like to call prompt engineering in the large. And this involves building much bigger systems involving many people, perhaps many organizations, over much longer periods of time, with much greater complexity, by organizing broader systems of reasoning and then sustaining these across the life cycle of these systems. And for those of you who have engineering background, or those of you who work as a mission engineer or a systems engineer or a software engineer, you're familiar with these concepts of engineering cycles. You've got to worry about design. You've got to worry about capturing the requirements. How do you convert the requirements into some kind of design or implementation? How do you test to make sure it works? How do you maintain these systems over time? These are much more complicated and challenging issues, and we'll see later that that's some of the exciting part that still needs to be thought through. It's kind of work that's in progress. So the key point to take away from all this is that these practices, prompt engineering in the small, prompt engineering in the large, help democratize computational thinking so that anyone can reason and create interesting things without having to write traditional code or write much traditional code, and without having to retrain the models. So it's really AI for all. So let me talk a little bit about the benefits of computational thinking and to re-show the screen. So using computational thinking allows us to lower the barrier to entry in both technical and creative fields. And for a relatively low price, about $20 a month, you can use these tools that are much more accurate than they would have been before. And what that's allowing us to do is move away from low-level programming languages that are full of accidental complexities like C and C++ and Java and Python and so on, to be able to use higher-level tools like Claude Code or ChatGPT Codex, which are good for more than just coding. And you can also go ahead and use various kind of interactive devices like the voice-activated mode of things like ChatGPT, which again are very valuable to have a dialogue, a Socratic interaction. And why this is so useful is it's allowing people who are non-computer scientists or non-programmers to be able to do computational thinking. You can be a doctor, a lawyer, an accountant, somebody who's doing things in national security but don't want to have to write code. And I found that particularly useful when I was a professor at Vanderbilt. People came for 20 years or so and asked me, how can we use computational thinking in our work? And we would say, we'll teach you how to program in Java or Python or JavaScript and so on. And people would say, I don't really want to learn to be a programmer. I want to use computation. And so these AI models allow a wider range of people to be able to appropriately leverage and use these technologies in their field. So let's talk about some of the consequences of what I call the democratization of computational thinking, meaning anybody can get access to this. And even the people who don't have $20 a month can get access to the free version. As we'll see, there are deficiencies with that to some extent, but at least it's available. So computational work and knowledge work is now becoming democratized and really commoditized at scale. And what that means from the point of view of what we teach our students at William & Mary is human value. What we bring to the equation has less to do nowadays with trudging through the manual analysis in isolation and more about how good we become at framing problems, what our judgment is, our critical thinking, how we validate and vet the results, and how we synthesize in conjunction with these tools. And believe me, they're not always right. So that's why what we do still matters. But we're really raising the level of abstraction at which we're working. The other consequence is that people who do knowledge work, which is most of the people who go to college, those types of jobs are under a lot more pressure than traditional manufacturing jobs. Manufacturing jobs have been under pressure from automation for a long time. But nowadays with AI, we're getting to the point where people are starting to ask some really interesting questions about what's the impact on the value of a college education, what's the impact on my career, especially as an entry-level person coming out of college. And there's a cliche that people say where AI won't take your job, but a person who knows AI better than you may take your job. And so what we're learning here is that the people who are going to benefit the most are the ones who are able to adapt and learn to collaborate fluently with our digital chat buddies and counterparts. And this is an evolving process. It starts by learning the basics. What's a large language model? Starts by applying those things in limited ways on tasks you already know the answers to, so you can make sure the results are correct. That gets to a point where you become fluent, and then you can start to apply these in more collaborative ways with yourself and your team and your AI agents. And then, of course, the real goal is to finally transform things for the better, either making your work and your team more productive, or in many cases, making it more collaborative, making it more creative. And I'll talk a bit more about the creative part later, because that's a part that people sometimes miss. But everything is not unicorns and rainbows. There are challenges. If you think back to 3 or 4 years ago when this first started in the end of 2022, there was a lot of challenges with AI tools hallucinating, coming up with ridiculous, farcical answers. I remember when I went to work at the Pentagon a couple of years ago, we had an AI model there that was approved for use inside the Pentagon, but it had some quirks. And when I asked it to explain who I was, who is Douglas Schmidt, it said, Douglas Schmidt invented the internet in 1970. Well, in 1970, I was 8 years old. So either I was a Mozart-like prodigy with networking, or the AI model was hallucinating. And of course, it was hallucinating. Now, this is still a problem, but it's becoming less of a problem. It's still a problem when people misunderstand the limits of AI. AI is not some infallible oracle. It knows what it's been trained on. And if it's trained on gobbledygook and you don't prompt it well, you'll get gobbledygook back. Likewise, you have to be very careful to apply the best practices for versioning, prompt engineering, context engineering, and so on. So here's how I think about this. And when I do this in my daily life, my encountering hallucinations is driven kind of asymptotically towards zero. First thing to do, use the right version of a large language model. Now, we'll talk later, probably in the QA session, about what's the right model. In general, ChatGPT and Claude are two of the best models. They're not infallible, but they're very good. Gemini is pretty good. It's very good at certain things. Copilot, which is Microsoft's offering as it comes in the retail model, is not particularly good. It's okay for automating sort of mundane administrative tasks like answering email and things like that, but it is prone to not being as good as ChatGPT or Claude. What's funny about that, of course, is that trying to pick the right AI model is kind of like trying to decide who's going to be the championship college football team next season. With things like naming, images, and licensing happening, you really haven't the faintest idea who's going to be the best team because it changes every year. Similar things are happening with AI. These models are advancing very quickly, but using the paid version, using later versions, usually puts you in a better place. Learning how to prompt properly, that makes a big difference too. There's some papers we've written about prompt engineering and prompt patterns. Learning how to do good prompting, which is really just an extension of thinking clearly, makes a difference. Something we didn't have time to talk about today was using context properly. And what that means is when you ask a question of a large language model, or ask it to do something on your behalf, if you give it a PDF file that contains something you wrote, or you give it some images that you want to use as the basis of what you've asked it to draw, or you provide context by links to other articles or other information, other primary sources, it'll often give you much better results. There's never enough critical thinking. You have to think critically when you ask questions of large language models. You have to think critically when you observe the results and try to figure out what to do next. So that is even more important than ever before, perhaps. Trust but verify, or maybe a better way to do it is to say, be skeptical of the output that comes out of AI and only trust to the extent that you spend time verifying it. And if you do all of those things, the results are much better. They're very rarely absolutely perfect, but they get a lot better. The goal of all these different steps, using the right model, using the prompt patterns, context, and so on, is to try to increase the trustworthiness of the output for what are inherently non-deterministic tools. They don't always give you the same answer the same way every time. By the way, human beings are pretty much like that too. We don't always answer the same way every time to every question, and we sometimes make mistakes as well. So what can we do to think about our AI augmented future? Some people think this is a fad, this is a trend, it's going to go away. I think of that as something like the Kubler-Ross 5 stages of grief. Some people are still in the anger and denial phase. At some point, when you reach acceptance, you realize that computational thinkers using AI effectively and responsibly are going to and will always henceforth vastly outnumber programmers. And that really comes from the democratization of computational thinking. We're no longer in a situation where only a handful of people who master the mysterious art of computer programming are going to be able to use computation in their line of work or their creative field. Anybody who spends time can do this. And the great news is very few people have more than 3 or 4 years of experience with this stuff. So the playing field is level. This has had a huge impact on the software profession. Software developers in cutting-edge companies are already writing much less code manually with traditional programming languages, and instead they're talking to AI agents, describing in natural language what they want them to do, and then they let the agents run and they work with the agents to see what the results are. There's an absolutely fascinating New York Times article from very recently, a couple months ago, that talks about this shift and this trend. And it's worth reading it because it gives you a sense of what's happening and the rapid pace of disruption in the computing field. This also means that we have to think about broader ways of making the results more trustworthy, better, accurate, more accurate. Quality attributes, things like maintainability and verification become super important because we want to make sure people can trust these results to build bigger and bigger systems. Part of this is still a research problem. We have researchers in our school here at William & Mary of Computing, Data Sciences, and Physics doing a lot of work on prompt engineering in the large to make this more reliable and trustworthy. And the goal is to be able to allow people to use these tools to solve problems without creating so much AI slop that the systems cannot be maintained in any reasonable way. So to kind of wrap up, generative AI can greatly accelerate productivity and creativity if we use it properly. If we don't use it properly, then it can accelerate chaos. And as almost always the case with any newer technology, engineering rigor is essential, but even more important is education. We spend a lot more time educating people how to drive safely when they're teenagers than we do how to prompt safely. At William & Mary, we have, our school has defined a holistic model of AI proficiency that we're using to make sure our students come away with a view of how to apply AI or create AI that's going to work wherever they go and whatever they do in an ethical, which means use it when it's appropriate, don't use it when it's not, responsible, which means don't allow yourself to have brain rot or skills erosion, make sure you stay engaged intellectually and cognitively, effective, which means learn how to use the prompt engineering and prompt patterns and context engineering properly. And then finally, the part that I find so fascinating is the creative part. By liberating ourselves from occupational bureaucracy and having to do a lot of mundane tasks that are tedious and repetitive, it frees up a lot more time to do the fun stuff, which is the creative part. And if you take a look at these two links, which I'll provide here in the slides, we've got a couple videos that talk about what our school is doing to help ensure that this AI proficiency model is something that all the students that we educate come away with. I've got lots more stuff on my website at my YouTube channel about generative AI you might want to take a look at. If you go to my YouTube page, you'll see the playlists that I have there. And then for further information about AI, I highly recommend you take a look at my friend and colleague at Vanderbilt University named Jules White. He has about 24 freely available MOOCs on prompt engineering that are on the Coursera platform. So a MOOC is a massive open online course. And so you can learn about all kinds of fascinating aspects of generative AI and prompt engineering and using it for many different things. So that's a great way if you're curious and want to have more systematic exposure to this, that's a good place to look. So with that, I will stop sharing and we can do some Q&A with Ali.
Thank you, Dean Schmidt, for that insightful presentation. I think one of the key takeaways from today's discussion is that AI is neither magic nor science fiction. Rather, it is a powerful set of tools that are already shaping how we work, learn, communicate, and solve problems. At the same time, as you've highlighted, understanding its capabilities and limitations is essential if we want to use it thoughtfully and responsibly. We're now going to transition to the Q&A portion of our program. Thank you to everyone who submitted questions during registration, and please continue to add your questions in the Q&A panel. We'll do our best to get to as many as possible during our remaining time together. To get us started, I'd like to begin with a question that several attendees asked before the webinar. Dean Schmidt, how can people use AI safely without compromising privacy? Is there specific information you should never share to an AI platform?
That's a great question. In general, you should avoid sharing things that you don't want to leak out beyond yourself or your organization, especially if you aren't really that aware of how the privacy policy of the large language model or AI tool you're using is configured. As an example, if you use the free version of most of these tools, then the inputs that you give it will be trained on by whoever you're working with, whatever large language model provider you're working with, and they'll train subsequent models on that. So if you give proprietary information, if you give your technical, latest technical work with data, or you give, God help us, social security numbers or other things, personally identifiable healthcare information, that will be trained upon. So you definitely want to avoid that. If you have certain institutional models, for example, at William & Mary, some of us have access to ChatGPT education, and they claim that they don't train on the data that is entered there. If you're super paranoid, then you probably still want to be very careful. And if you're super paranoid, which is not necessarily a bad thing to be, you might want to go to the trouble of setting up a large language model that runs on your computer and doesn't access the outside world at all. That's probably the safest way to go. But just be careful. Don't put information in that you would not want people to have access to.
Thank you for that response. Another question that people ask very frequently was, how do you know when AI got something wrong or hallucinated? Are you able to fact check these answers? And are there ways to help mitigate this from happening?
Yeah, that's a great question. I pretty much always assume AI has got something wrong. So even though it oftentimes doesn't. But if you go in there with that attitude of, I don't trust it until I verify it, then you're in a better position. And the way to do that, of course, these are all the skills that we learn at William & Mary over the past hundreds of years. Go and look at primary sources, check the results, check your work, get a second opinion or maybe a third opinion. And that's even easier to do nowadays. But the other thing I'll mention is if you really want to get results that are less likely to hallucinate, become accustomed to using the more advanced reasoning modes in these AI tools. For example, ChatGPT, like all the other AI models, typically has something they'll call deep research or deeper research. And what that does is it really goes and takes its time, and it double and triple checks its own work, and it'll come back with results that actually have links to where it got its information from. So that way you can go out and see, do I trust the sources it used to come to the conclusions it did? So always go in there with that sort of like the strategic arms limitation talks mentality of trust but verify. You want to make sure that you don't fall into the trap that some lawyers fell into a couple years ago, where they created a brief that had a bunch of references to fabricated cases that didn't exist. And I think they got sanctioned by the judge. That's a bad look. So be critical, use judgment, have metacognition, all the things that we've learned at William & Mary for forever.
Thank you for that. We're now going to look at some of the questions from the audience. So, given that prompts are sloppy because they are natural language with lots of ambiguity, how can this lead to results that are anything but sloppy? How can I improve my prompts?
Oh, that's a great question. I think this is going to sound funny. Taking courses in philosophy and English and learning to write and read succinctly and concisely, study the works of Hemingway as opposed to the works of James Joyce. You follow the Hemingway model of conciseness, not the Joyce model of stream of consciousness. Those are the starting points. If you want to get more adept at this, then I highly recommend you take a look at some of the videos that Professor Jules White from Vanderbilt has on Coursera, because he has a whole set of videos on prompt patterns for prompt engineering. And what you learn there, it's absolutely fascinating. You can learn to structure your engagement with large language models in such a way where it really will give you very precise answers in very well-structured output formats. And so you can use it if you're willing to take a little bit of time to learn these prompt patterns. You can be a lot more effective. You can be a lot more lean in your interactions. The other thing I'll mention also, very important here, make sure if you really are trying to go for accuracy, use the more advanced, usually paid models. The open free models are okay, but they're more likely to do things like say that you invented the internet than actually give you an accurate representation of whatever it is you're asking them to do. Also be aware that certain topics with certain models are less well trained. This is becoming less of an issue, but a couple of years ago, if you expected ChatGPT to do advanced mathematics, it didn't do a very good job. They fixed a lot of those problems. But if you really want to amuse yourself, go to Copilot and ask it to provide a seahorse emoji. And for all kinds of very humorous reasons, that causes Copilot, the Microsoft Copilot, to absolutely lose its mind. And it's actually somewhat funny to watch this. But the key thing is, as almost always is the case, education and learning to be precise and concise with your language.
Thank you for that. Another question we received was, you say computational thinkers will outnumber programmers. Will the programmers continue to do the heavy lifting of life cycle architectures, security, and large systems, with computational thinkers more at the edge of enterprise systems?
That is such an interesting question. I think for the moment, yes. For the moment, if you think about AI proficiency as a pyramid, then at the apex are the people who have the very deep computer science skills, the very deep mathematical skills. They're the ones who are creating the AI models. They're the ones who are training them and vetting them and so on. And that's great. We need those people. We graduate those people from William & Mary. We love those people. Those are our typical computer science majors and so on, data science majors. The vast part, though, the part in the middle, which is what I call AI fluency, those are more the people who are becoming power users of AI. They're not necessarily building AI, although increasingly they will be programming agents. They won't be programming agents in JavaScript or Python or C. there'll be programming agents through agentic programming environments, which will be based on natural language and other context. So I think there are going to be lots and lots and lots of those people. And a lot of those people would historically have been computer science majors, but they realize that they can solve much bigger problems by thinking more broadly with the use of these newer agentic tools. So yes, we definitely need computer scientists and we need some of the traditional computer scientists, but over time, I think we're going to see a massive shift. So we need people who are really good at doing agentic programming, and then most people are going to have to be good at using the agents. And so over time, as these tools get better, the roles will shift. But I think the good news is there is a tremendous demand now for people who know how to build trustworthy, reliable, efficient, secure, et cetera, systems using these agentic toolkits. And they're just not nearly enough of those people. We're really moving hard in our curriculum at William & Mary to make sure that students who want to have those skills get those skills by the time they graduate.
Thank you for that. So we're going to move on to our final question. So is there an everyday, not work-related task that you have been able to streamline and save time by using AI?
Oh, absolutely. So you probably, if you look carefully at my slides, they're all pretty much everything is AI generated one way or another. And so I find literally in the last month, the tools for creating images and videos have gotten extraordinarily better. First and foremost, they can spell correctly, which was always a problem for before. And they tend to do a pretty good job drawing hands, which they couldn't do before. So these tools are increasing very quickly. And so a lot of the stuff that I do, either through my work or music that I do, I like to play music. And when I play music, then I like to be able to create imagery to visualize whatever I've played. Think about album cover art from the 60s and 70s, which was very psychedelic, like Cream, Disraeli Gears, and so on. And you can use AI to do all kinds of cool things that are very visually interesting. At least they're visually interesting to me. So that's probably a good example of non-work related stuff that I use AI for. I just find it fun to create and visualize things. I'm not a graphic artist, but I like visualization. And so the ability to use these tools to help bring my sort of nerdy, computer sciencey, geeky things to be more visually interesting is something I find very appealing.
Thank you, Dean Schmidt, and thank you all for the thoughtful questions. But unfortunately, that's all the time we have for Q&A. As we wrap up, Dean Schmidt, do you have any closing comments?
Sure. Most important thing I think is to try this stuff yourself. It's kind of like the old Nike phrase, just do it. In my experience, the people who tend to be AI skeptics and who don't like it haven't used it very much, or haven't used it lately, or haven't used the right tools in the right way. And so try it on something that you find interesting. Try it on something that is a boring task that you'd like to automate, and play with it. Give it a chance, see how it works. And also, please feel free to join us for the next session where we'll do more hands-on examples. The one I showed today with Opal was just kind of a teaser to demonstrate the point of computational thinking with agents, but there's all kinds of really interesting things that we can do together to learn more.
Thank you, Dean Schmidt, and I want to thank you all for joining us today. We were unable to get to every question submitted, but we will work with Dean Schmidt to provide responses to as many of the remaining questions as possible, and share those answers with attendees via the email addresses used during registration. We would also like to thank the Alumni Association and the Lifelong Learning Series for providing this topic to bring our community together around such an important and timely topic. The recording from today will be posted on the Lifelong Learning website within the next week or so. And we hope you will join us for the next session on July 17th, where we will demonstrate practical ways to use a variety of AI tools in both your personal and professional life, helping you move from understanding what AI is to exploring how it can be used effectively in your day-to-day work and activities. Thank you again for being with us this evening, and we appreciate your continued support of William & Mary, your commitment to lifelong learning, and your willingness to explore new ideas with us. Have a wonderful day.